Hey, what's up? We've gotten so far, you're almost at the end. We got one more lesson. It's going to be on volume. So this first section answers numbers 1 and 2. So as for which is larger, your paper says longer, it should be larger. For the first part, 1 liter or 1 gallon, 1 gallon is larger. For the second part, a liter or a quart, 1 liter is bigger. And then for part C, 1 milliliter or 1 fluid ounce. 1 fluid ounce is larger. So this is number 1 here. And then number 2 is these three things for the 1 gallon equaling 3.79 liters. 1 fluid ounce is equal to this one. And then your quart one is here. So this next part will cover numbers 3 through 7. For number 3, volume is the amount of space an object takes up. Number 4, the base unit of volume in the metric system is the liter, and you represent that with either capital or lowercase l. However, I think most people prefer that you use the uppercase one because it is easier to tell the difference between an uppercase L and something like a uppercase I. For number 5, the standard is that 1 liter is equal to 1 cubic decimeter. So there's the word there. And then for number 6, 1 liter is equal to about 1,000 milliliters. And then 1 milliliter is equal to 1 centimeter cubed, or cc, or 1 gram. For number 7, for the which is larger game, between 1 liter or 1,500 milliliters, I mean, you guys can use this conversion rate. 1,500 milliliters would be equal to about 1.5 liters, which would make this one bigger. For B, between 200 milliliters and 1.2 liters, you are going to see that the 1.2 liters is larger because this would only be about 0.2 milliliters. And then for part C, between 12 centimeters cubed or 1.2 milliliters, 12 centimeters cubed is going to be the biggest because, as you guys remember, 1 centimeter cubed is equal to about 1 milliliter.
Liter. Measure volume of gasoline.
Or the volume of most any refreshing beverage.
Volume is the amount of space in a contained substance, like water in a swimming pool, measured in liters. Which has more, 750 milliliters or 1 liter?
You're absolutely right. There are exactly 1,000 milliliters in 1 liter.
This section will cover questions 8 and 9. Yay! So for number 8, which instrument will we be using to find liquid volume? You will be using the graduated cylinder, which is pictured over here and here. This one is a close-up view for one of your next sections. So for number 9, whenever you read a graduated cylinder, you are going to use this little liquid curve that you see at the top of the water. This is caused by what they call surface tension and, I believe, adhesion of water. But when you are reading that curve in a graduated cylinder, you are always supposed to read the bottom part of that, and wherever that bottom part hits the line. So I'm going to erase all this so you can see real quick where that bottom part touches the line. Do not read the top part, okay? It should be the bottom part. And by the way, for number 9, that curve is named the meniscus. So for number 10, whether you're working alone or with a partner or whatever, I'd like you to briefly pause and figure out for yourselves what is the volume in each of these cylinders. Now, they went easy on you. There's no meniscus, no curve on these, but still read to the nearest place. Okay, so pause. Okay, and now you are unpaused. For this first one, if we read it, looks like between 50 and 60, each of the tiny lines is just worth 1 milliliter, so I'm going to count up about 1. This one looks like 52 milliliters. For this next one, it goes up from 35 And again, it looks like each tiny line is worth 1, so it'll be 35, 36, 37 milliliters. And for your last one, you gotta be careful with this one, because see how it goes from 20 to 25 right between here? So that means these two little sections here are each going to be worth 2.5, which would give us for this one about 22.5 milliliters. So you always got to count the lines if you're unsure, because it would make no sense if this was worth 1, right? Sometimes they're different. Be careful. So this slide answers numbers 11 through 14. So for 11, what formula do we use to find the volume of regular objects? It's going to be the one we've discussed, length times width times height, which will be, I mean, there's always some debate over like what counts as length, width, whatever. As long as you get 3 different numbers, so for this cube, for example, you will be good. And so for number 12, the volume of the cube, we're just going to multiply those. 9 times 8 times 10 gave me 720. And since that's centimeters for each one, centimeter we multiplied 3 times, it's going to be centimeters cubed. For number 13, we can find the volume of what they call irregular objects, so things that aren't perfect cubes, using the graduated cylinder method. And so for that, you get 2 volumes, so one is the amount of water with the object in it, which looks like it's about 260 milliliters, and then the amount without the object looks like it's about 200 milliliters, and then you get the difference of that, so 260 minus 200 is going to get you 60 milliliters for that rock, which will be number 14.